So I think a video would be better than trying to type out all this stuff, because I can point and stuff. But so here, all the formulas and our, arithmetically, changing payment stuff. Let's focus on these two. So there are a lot of symmetries, I guess, or there's just like this, I guess a symmetry. So the theme is, I like one and I don't like the other because I like things that are ready to go, quote unquote, which means I like things I don't have to convert. So I prefer I over D because I usually start with I and I have to solve for D, right? And because I prefer I over D, I prefer annuity immediates over annuity dues because, with annuity immediates, you only use I and it's ready to go. With annuity due, you either have to convert it to annuity immediate or you have to calculate D. So I like, because I prefer I over D, therefore I prefer annuity immediates over annuity due. And, this theme helps you map, these two things. So the decreasing annuity is going to be associated with things you like. The increasing is going to be associated with things you don't like. And it's almost too perfect. Not only do you have an annuity immediate in the numerator, but the other way it maps out is like, not only do you have an annuity due, but both terms in the numerator need some work. So this one, who's the representative of things we don't like? It's definitely going to be this one between the two. This one, everything in the forget the denominator, easy, right? It looks like a regular annuity. Everything in the numerator for a decreasing is ready to go, and it's easy, right? But everything in this one isn't ready to go. So that's the theme I use to remember the two. I don't know. And I'm going to point this out. Just don't let this give you the creeps. I angle n, is angle n, it does exactly what you expect. The a angle n becomes an s angle n. The nv to the n just becomes an n. The n becomes an n accumulated to, oh my god, I forgot to write to the n. And the a angle n becomes an s angle n. It works fine. Right, you don't even need to memorize these. I did, but I have a flashcard for it. But you don't even need it. All you have to remember is that it does exactly what you expect. No, there are no tricks. There are nothing to watch out for. So now we have the PQ formula. That's what I call it. And there's nothing really to show here. Messed up a bit, but whatever. I'm also going to point out it does exactly what you expect when you turn it into S angle n. I forgot the ends. It does exactly what you expect. The accumulation factor distributes both these terms. The angle n, boom, S angle n goes in here. Angle n, S angle n, n to the v just becomes n. No surprises. Now on to a really common shortcut that I use. Sorry. I've had some multiple takes. So, all right, here's an example, right? So it's a bunch of payments, right? You see this increasing here, and for mine, it usually becomes a perpetuity, but that's not really necessary for you to use it. And Dave, uses this as like an idea of what's going on, and then he talks about how shapes. I know that's a really bad right triangle I made. Try to straighten it out. You could think about this just extending out here like this, and what would this correspond to? What does this mean? This. Well, actually, let's go to the original formula. So, the way I did it, you have an increasing annuity to 5, then you have two stragglers, right? And they go to here, right? So you have an A angle 2, 5A angle 2. Then you discount it, boom. So that's what I use, right? And that formula corresponds with that shape. What formula can correspond with this? Well, so I have, this, just a rectangle would be 5 angle, whatever, right? This is an immediate, or increasing, right? So, with this, I don't know. I can't give an intuition. It just, I don't know. I'm too tired. Decreasing, boom. So, You have to subtract something, right? With this one, you know, I mean, yeah, it's just, it makes sense, right? But like, it's kind of a mess. It's ugly. This is so simple. Not, I mean, and like, oh my god, and you have your friend, the one that's simple, easier to calculate. This is so much easier. Highly recommend it. I do this a lot, man. I'm not gonna lie. I love that. So that's like my favorite shortcut, and a lot of how I think about um, these things. And just to recap, there are symmetries. But like they're like two like you don't like one and you like the other. So like the numerator, everything's easy, and the numerator here, everything's hard. And numerator, it's easy because you don't have to accumulate it. This one you don't have to change. This one's hard because it's annuity due and you have to convert it. And this one you have to discount, right? And then also like where's n? So it's like n on the left over here, and then like n's on the right over here. There's just lots of symmetries, I guess. I really don't know what to call it, but that's my intuition. This is getting longer than I expected, but I hope that helps, man. Great, best of luck to you.